All right, we have finally reached Unit 8, our final unit. We're going to review some algebra and geometry connections here, starting with our distance formula. We can use our distance formula to find the length between 2 points. We just need to write down our 2 points and plug them into our formula, and it will calculate the distance for us. The distance formula is the same as an application of solving the Pythagorean theorem. So on paper, you might be more comfortable drawing the right triangles and finding the hypotenuse. We'll review both of those things when the time comes. Now, let's talk about slope. We know that the slope is the change in our y values over the change in our x values, rise over run. And we need to be aware of our area formulas for a rectangle, length and width, and the area of a triangle, 1/2 the base times the height. Be reminded that perimeter is the sum of all of the sides. So let's jump into this problem right here, and it says find the area and perimeter of the figure below. Well, it doesn't tell us what kind of figure it is, so let's double check. To me, it looks like a rectangle, but in order to be a rectangle, we would need to have 4 right angles and opposite sides parallel. Would be good enough to tell us that it is definitely a rectangle. We can see that the sides are not going to be congruent. So let's go ahead and check that. So I'm going to need to remember that my slope, right angles or perpendicular lines, have opposite reciprocal slopes. So that's important. So we're trying to figure out, is it a rectangle? Because that's going to be helpful. So let's take a look at 2 of these lines right here. We'll take a look at this guy right here and this guy right here, and we'll figure out what the slope is. So to go from this point on the left to this point on the right, we would need a positive change in our y value of 2. So the slope there is 2. And we would need a positive x value change of 8. So 2 over 8, which reduces to 1/4. Let's check the slope of this green segment here. Our vertical change would be to move down 4. And our horizontal change would be to move right 1. So when we compare 1/4 and -4 over 1, we do have opposite reciprocals here. So I'm going to mark this as a right triangle, or a right angle here. And let's check down here. This line also has a vertical change of 2 and a horizontal change of 8, meaning that these two are reciprocal to one another. These 2 slopes are reciprocal, which means this guy is going to be another right angle. And if we look down here, this is a -4 vertical change and a +1 horizontal change. So this is perpendicular to both of these. So we do have a rectangle here. So now what we know is that we don't need to find all of the sides. We only need to find the length of one short one and one long one. So let's do that now. Let's find the length of this red side right here. We use the distance formula. This is the point -4, 2. And this is the point 4, 4. So if we're looking for the distance between these 2 points, let's write them down over here. -4, 2 is x1, y1, and 4, 4 is x2, y2. Now, you can type these into your calculator, into the formula. You can do this piece by piece, which is what I like to do. I like to do our square root symbol, and we do our formula do x minus x, so 4 minus -4 is 8, and 4 minus 2 for my y minus y is going to be 2, and we've got 64 plus 4, so the square root is 68, which is 2 square roots of 17, which is about equal to 8.25. That means this side over here is also 8.25. I know that when we've talked about this, we've also talked about using the right triangle method, so drawing a right triangle and getting the distances that way. That distance is 1 and that distance is 4. So the Pythagorean theorem says 1 squared plus 4 squared is c squared. When I solve this for c, we can see that it basically just ends up being the distance formula. And we have 1 plus 16, which is the square root of 17, is equal to c. And the square root of 17 comes out to be 4.12. Rounding, of course. So we have both of these sides here, and we can add them up. First, let's get an exact value. Our perimeter would be 2 square roots of 17 plus a square root of 17 plus 2 square roots of 17 plus a square root of 17. And when we add all those up, we get 6 square roots of 17, which is about 24.74. We're asked to find the area of the rectangle. Well, that's going to be the length times the width. So the length was 2 square roots of 17, and the width was the square root of 17. So we get 2 times 17, which is 34 units squared. Now, we can do all of this in Desmos as well. We're not going to be able to get the exact simplified answer, but we can get a rounded answer, which can help us find the correct answer choice on the test. Here you can see that I already have the distance formula typed in to Desmos, which you can do directly off the formula sheet. And then all you have to do is go through and take your x1, y1, x2, and y2 and define them in Desmos. So if you come down here after typing in the formula and you say your x1 is equal to -4, and your y1 is equal to 2, and your x2 is equal to 4, and your y2 is equal to 4, and scroll back up, the formula will tell you that it comes out to be 8.25, which is close to what we got here. It is what we got here as our distance. And then we can repeat that and go back through and put in our points here if we wanted to, or we could even use the Pythagorean theorem and have Desmos solve the Pythagorean theorem for us. We said up here that we had 1 squared plus 4 squared is equal to c squared. If we type that in, 1 squared plus 4 squared, and instead of using an equal sign, we use our wavy line and then type in a c squared, Desmos will think that you're doing a regression, and it will calculate the distance to be 4.12, which is what the square root of 17 comes out to be. So you would not be able to get the exact simplified answer, but you could figure it out based on the decimal approximation. To do the area using that, you would have, multiplied 8.24 times 4.12, and that comes out to be 39.94. And if your answer choice is 34, then you're going to know to go ahead and choose that answer choice as well. So keep in mind that when you round answers as you go, you do run the risk of not having the exact right whole number answer should it be a whole number. But that's how we can use Desmos to find the perimeter and the area. All right, so let's go ahead and move on to midpoint. When we move on to midpoint, keep in mind that we can put our midpoint formula pieces into Desmos as well and define x1 and y1. So a landscaper wants to position a sitting area halfway between the garden shed of the swing set, determine the coordinates of the sitting area. So we can do this really what I would refer to as the long, hard way. So we got the point 3, 9, and we have the point 10, 4, and we can go through here and use our midpoint formula, which says to add the x's, which would be 13 divided by 2, and add the y's, which would also be 13 divided by 2. Both of these are 7.5, so if we went to 7.5, 7.5, should be about right there. Sorry, not 7.5. 13 divided by 2 is 6.5. Gee golly, that's a big mistake right there on my part. I just wasn't really paying attention. So 6.5, 6.5. 6.5, 6.5. Again, you can use Desmos here. We've defined our pieces of our formula, so we can just go in and say x1 is 3, and y1 is 9, x2 is 10, and y2 is 4. And it says 6.5, 6.5, and I would not have made my calculation mistake there. So that is really the long way to do this. When we have an image and we want the halfway point, we can just draw this line between them, turn it into a right triangle, and then count the distance. We got 1, 2, 3, 4, 5. Half of 5 is 2.5. So there is our midpoint right there at 6.5, 6.5. You could have also done this down here at the bottom. We got 1, 2, 3, 4, 5, 6, 7. Half of 7 is 3.5. So I go 1, 2, 3.5. And that would have taken me up to the halfway point of our line, which is the midpoint. Let's continue on. Parallel and perpendicular lines. We know that parallel lines have the same slope, and we know that perpendicular lines have opposite reciprocal slopes. So let's go through this and review. So here we have an equation. It's given to us in slope-intercept form. So let's review slope-intercept form, which means we have a given slope of 1/2, and we want a parallel line. So our new line, its slope is going to be 1/2, and we want it to go through the point -2, 4. So I've already got our basics here. Here is the line -1/2 x minus 2. Here is the point -2, 4. We want a line parallel to this black line going through that red point. Well, what we know here is that our new line in slope-intercept form has to be, or start with, 1/2 x, because that's what's going to make it parallel. So I'm going to start with -1/2 x. Sorry, -1/2 x. And we can see now that our blue line is parallel. And we can also see that our blue line is not far enough up to go through the red. So we're just going to add some. I'm just going to guess up 3. If I had guessed up 2, I would need to go back and alter it with a little bit higher. If you had overshot it and pressed 6, you could go back down to 5. That's too little. 4's. All right, 3. There we go. Perfect. So this is just going to be -1/2 x plus 3. Again, if you've got a list of answer choices, you can always type in your answer choices and figure out which one is parallel going through the point they give. Example 2 here. Here we're talking about perpendicular. So our given slope is -1/2. Our perpendicular slope, we need to turn it upside down and change the sign, so +2/1. So we're going to start with y equals 2 this time, or y equals 2x. So y equals 2x. We can see that that's perpendicular, but it's not far enough up. So let's add a little extra. 2's not enough. 5's not enough. 7's not enough. 9 is too much. 8 is perfect. So y equals 2x plus 8 is perpendicular going through the point that we've been asked for. Moving along, it says, below are equations of 5 straight lines, A, B, C, D, and E, which 2 lines are parallel to one another. So what we need to do is we need to type all of those in to Desmos, and I just closed the tab where I had already typed them all in. So let's just go ahead and type them all in here. So let's go ahead and clear that out, and we have y equals 4x minus 9, and 2y equals 4x plus 11. Those two are not parallel to one another. Let's keep going. 4y equals 15 minus x. Oh, well, I found a pair of perpendicular lines. So it looks like line A and line C are perpendicular. So let's go ahead and fill that in down here, A and C. And let's keep looking for a pair of parallel lines. So let's go to our next one. We have 3y equals 2x plus 5, still nothing parallel. And then y equals 2/3 x. Oh, it looks like the blue and the green are parallel, so that's going to be D and E. So we can just use Desmos to find those parallel and perpendicular lines.